Good morning, students. So the next topic from the talk is electrostatic potential and potential energy. So potential itself says that it is something like work done. Work done only is stored as potential or potential energy. So what am my consideration here is plus Q is taken, and if I am going to have a test charge also is going to be plus Q. So what will happen? There will be an repulsion. So there is an repulsive force acting between plus Q and Q naught. So what happens now is that there is some external force which has to overcome this repulsion. That work done to overcome this repulsion is what is stored as potential energy. So work done will be equal to W will be equal to integral of R to P. What's the meaning of R to P is when the charge is going to move from Q naught, which is there at the point R, to the point P. Okay. So F external dot dr. Always we know that work done is nothing but force into displacement. Force into that displacement vector is what is this dr vector is. So but we have already studied in the Coulomb's inverse square law. At stationary, it has some other force, but when the charges are going to move, there is a force which is called as Coulomb's force, which is acting opposite. That is why it is written as F external is equal to minus F Coulomb. So UP is nothing but potential energy with Q naught at P, and QR will be nothing but where potential energy associated with Q naught at R. So what will be the work done? Work done will be equal to del U. What's the meaning of del U? Change in the potential energy. That is, what is the potential? The difference between the potential energy at P minus U, R. That is, when you integrate this and apply the limits, what will you get? Upper limit minus lower limit. The same here, upper limit is UP minus UR. So ultimately my expression is only this one, which is going to be equal to integral of R to P, where it is F external dot dr. So now the expression will be F external is equal to minus F Coulomb. It is because the charges are moving. So when charges are going to move, there is a force which is called as Coulomb force, which is going to be equal to minus Q naught into E. So when I substitute here, in the place of F, I will have minus Q naught E vector dot dr vector. And this Q naught is a test charge which is taken outside, and it's a positive, so a plus is written here, and then minus E dr. This is del U value. So potential energy per unit charge will be equal to del U by Q naught. So this Q naught will get cancelled. So at last what will I have? I will have the equation as is that equal to minus integral R to P E vector dot dr. So this is what is called as electric potential difference between P and R. So del V, this is potential difference. And what you studied del U was potential energy. This is potential difference. So that is why it is written as V. V only is always potential difference. So Vp minus V.